Hi. Hi. This is Miss Melinda. Welcome to Miss Melinda's Spontaneous Smart Diva Show. So tonight we're going to do some more neurology and neuro terminology. I really got excited when I taught. I don't know if I've taught the past few days, two neurology or three. I'm not sure, but not many, like two or something. And so I wanted to stick with this because it's refreshing. It's refreshing. So I'm going to have to try standing, I think, because it just is not in a good way. There, this is better. Okay, right like that. So, we're doing neurons, okay? So we're studying neurology, the study of the brain. Ology is a suffix. And the suffix ology always stands for the study of. Biology, the study of biology. Ology, the study of bio. Legal terminology, the study of law. And I made up neuro terminology. That's the other. That's what we're gonna do. Do some neuro words. Well, I'm not gonna do the neuro words today. I guess I didn't get to that. So I'm doing neurology, the study of the brain. Okay, so this is neurons, also known as, quote, nerve cells, are essentially the cells that make up the brain and the nervous system. Neurons do not touch each other, but where one neuron comes close to another neuron, it's called a synapse. SYNAPSE. So next time you watch this, get a pen and paper and write down synapse. SYNAPSE, in case you don't know it. So it says neurons do not touch each other, but where one neuron comes close to another, neuron, a synapse is formed between the two. According to research, the human brain contains around 86 billion neurons. Now you tell me, how do they count 86 billion neurons in your brain? How can they do that? They have to have some kind of electrical device to get into your brain and count to a billion? I again didn't elaborate on billion and how they get to the conclusion. I think I did ask it today, and it took me in, and I guess maybe I wrote a bunch of stuff, so maybe we'll get some of it. Okay, so neurons do not touch each other, but where one neuron comes close to another neuron, a synapse is formed between the two. According to research, the human brain contains around 86 billion neurons. Herculano Housel, the year 2009. I guess, I don't know, they might have a person's name has something to do with this discovery, maybe. Neurons, the information processing units of the brain, responsible for sending, receiving, and transmitting electrochemical signals throughout the body. Neurons. Dendrites are projections of a neuron. So a neuron is also called a nerve cell. Neurons and nerve cells are the same thing, that receives signals, okay? So, info from other neurons. Oh, let me reread this. The dendrites are projections of a nerve cell, that receives signals, info from other neurons, okay? Receives information from other neurons. The transfer of info from one neuron to another is achieved through chemical signals and electric impulses. That is electrochemical signals. The information transfer is usually received at the dendrites through chemical signals. Then through chemical signals, then it travels to the cell body called soma, parentheses, SOMA. Okay, continuing. Along the neuronal axon. Now, I've known axons and dendrites for years. So axons are the ones that send the messages to the dendrites. I'm just telling you that out of my head. Okay, so along the neuronal axon, as electric impulses, and it's finally transferred onto the next neuron at the synapse, synapse, which is the place where the two neurons exchange info through chemical signals. At the synapse, meet the end of one neuron at the beginning, the dendrites of the other. And then I'm going to keep talking, but I'll show you this picture later. Okay, so the functions of dendrites are to receive signals from other neurons, to process these signals, and to transfer the info to the soma of the neuron. Okay? Receive info is the next title. Receive info. The dendrites resemble the branches of a tree in the sense that they extend from the soma or body of the neuron and open up into gradually smaller projects. At the end of these projections are the synapses, which is where the info transfer occurs. I can't hold it anymore in that hand. Yeah, it's hurting too much. Okay. Let's try the next page. Okay. So the next page, I'm going to try sitting down. Maybe if I can hold it up with this hand. That's not bad. But we got to look this way. But the lighting F's me up. That's the problem. Let's see if we could turn the chair around. Try it this way. Okay. There. This is not looking right. Okay, let's try this. More specifically, synapses are the site where two neurons exchange signals. Change signals. The upstream or pre-synaptic, quote unquote, neuron releases neurotransmitters, parenthesis, usually at the end of the neuron. Okay. Also called axonal terminal, quote unquote, Axonal terminal. It's an axon terminal, but axonal terminal. Okay. And the downstream or post synaptic neuron detects them usually in the dendrites. Look up neuron. The picture synapse of a synapid. They got a picture of it. Oh, here, let's see if I can show you it. Just wait. Okay. So here's kind of like a picture. See, like that. Okay. Let me see. I got it. See, now look. What? I got my hands in the way. Okay, here. There's the pictures. The two top ones are like the way they look. And there's some words to it. All right. So, okay. And the next is, there, if I hold it up, neurology continued. At the synapse, the presynaptic, the presynaptic, where are you at? At the synapse, the presynaptic neuron releases neurotransmitters, okay? Number 2 in the figure. Well, we don't have the picture. Okay. Which are molecules that time, quote, postsynaptic, unquote, neuron detects the postsynaptic neuron. So can detect the neurotransmitters because it has neurotransmitters receptors. See, it has neurotransmitters receptors, so they can receive the info, to which the neurotransmitters bind, okay, B-I-N-D. Okay, if the postsynaptic neuron does not have the specific neurotransmitter receptor, then the neurotransmitter will have no effect. Examples of neurotransmitter are, I'm sure you heard of this word, dopamine, serotonin, and the now this one I don't know, norepinephrine. It's Norep. If you have a pen next time, write it down. I'll have to look it up after class. Norepinephrine. Norepinephrine. Sounds weird. But we know dopamine and serotonin, and then GABA and glutamate. So that one hard word I'll have to look up and tell you guys, or you can watch this another time and be prepared to write the spelling off the video. If, for instance, a presynaptic neuron releases dopamine, the postsynaptic neuron will need dopamine receptors in order to detect the signal and consequently receive the info. Okay, page 8. So, some types of neurons have dendritic spines on the dendrites, which are small, don't put that paper there, which are small, protrusions, that's right, dendritic, okay, dendritic spines on the dendrites, which are small protrusions that project from the dendrites and watch of neurotransmitter receptors that increase the detection of neurotransmitters. It says look up pic of dendritic, dendritic, dendritic spine, quote unquote, in this micrograph. You can look that up and get a picture. You just Google, you say, I want to see a picture of that. Just watch it again and write down the spelling. Okay, and listen to this video over and over. So, neurology, process information. Once the neurotransmitter binds to the neurotransmitter receptor in the postsynaptic, quote-unquote, neuron, a signaling cascade starts that enables the info to be processed at the synapse. This signal cascade depends on the neurotransmitter and neurotransmitter receptor. There are excitatory neurotransmitters such as glutamate and inhibitory. Neurotransmitters such as glutamate and inhibitory in neurotransmitters such as GABA. Okay. Not too much longer, but my pinky can't hold out any longer. Oh. Or my arm. Oh. Oh. So, this next one, GABA. Okay, the neurotransmitter receptors begin signaling cascade that activates certain ligand-gated. I'll have to look that word up. Ligand, ligand, gated, gated, if you want to look it up. But maybe the meaning is in these notes. So, ion channels, ligand-gated ion channels enable ions to enter the neuron, and it has like either physics or a chemistry, one of the two. And then it says, or sodium, calcium, chloride, respectively, or to exit the neuron. It says E.g., period K, something, or potassium. Okay. So, biology defined dictionary. This is what a dendrite is in a dictionary definition. But this is just one sentence, okay. So, a dendrite is any of the protoplasmic protrusions. Okay, again, biology defined. A dendrite is any of the protoplasmic protrusions. Okay, and so we just got a few more pages, but I was going to continue with this whole study here. I said, no, it's too much for them. They're going to lose interest, and I will too. And we're not, I have to show you guys and myself a little at a time. I can't just because I'm in the mood to stay up because I keep sleeping in too late. You'll lose interest if I just push and push and push that a same subject. You can't push and push any same subject. That's why we're on neurology, something different. Okay, so dendritic branch. What the hell? Okay, redirects here for the dendritic cell. I can't hold it no more. I just can't hold it. It's hurting me like hell. Let's try it this way with my right arm. Okay. Okay. So let's go like this. Okay, quote, dendritic branch. So like dendrites, dendrit, but they put IC instead of ES. Instead of dendrites, it's dendritic. Dendritic, okay? So quote, dendritic branch, unquote. Redirects here for the dendritic cell of the immune system. This article is about neuronal dendrites in biology. A dendrite, from Greek tree, quote unquote, or dendron, is a branched cytoplasmic cytoplasmic process. Okay, quote unquote, cytoplasmic progress that extends from a nerve cell that propagates the electrochemical stimulation. Okay, and then from a nerve cell that propagates the electrochemical stimulation received from other neural cells to the cell body or soma, S-O-M-A, of the neuron. I don't know which way this looks right. Better that way. Yeah, better up. So, electrochemical stimulation received from other neural cells to the cell body or soma, quote unquote. Neuron from which the dendrites project electrical stimulation and transmit it onto dendrites, but upstream neurons. Usually, it's usually via their axons, which I'm familiar with, via synapses, which, all right, which are located at various points throughout the dendritic tree. Okay, dendrites play a critical role in integrating these synaptic inputs and in determining the extent to which action potentials are produced by the neuron. Okay, the neuron contains dendrites that receives information, a cell body called the soma, S-O-M-A, and an axon that sends info. See, I've known that for a long time. The axon sends the messages, and the dendrites receive the messages, okay? So it says, and an axon sends info. Schwann cells make activity move faster down the axon synapses, allow neurons to activate other neurons. The dendrites receive a signal. So here when it said Schwann cells make activity move faster. So I guess Schwann cells is the name of these cells that makes the activity move faster. Okay. So Oh, we got one on the last page. Okay. Well, I didn't do too bad. It was hurting, but I got pretty good through it, I think, through the class. So axon dendrites. The axon, and this is somebody's name, I think, Hillock, Funksels, not sure. The signal to the initial segment, and the initial segment triggers the activity, action potential that is sent along the axon towards the snaps. And then you can see this site. If you want to look up this site, it's learn, like you learn something, and bio, it's one word. Learn bio, one word, .org for interactive version. So that's basically the whole class. I want to get away from my hair looking like I'm on the bald side of my hair. So, yeah. So, how'd you guys like this class? I think it's very interesting. I think what I am learning is with. Oh no. Help! I lost it. I think what I am learning is that I had lost you guys. Sorry. I think what I am learning is don't teach too much of the same part of a class for very long, because people just are going to get bored and quit, including myself. And it's just like, I don't want to finish this video. Yeah, we could come back in a few hours and finish, or the next day or a few days. But the bottom line is, I have learned every subject I'm going to teach. I'm going to teach, the dendrites, axons. When I looked up the dendrites, it went on and on and on. And I said, no, you ain't going to keep going, because people just aren't going to keep reading it all in one video like that, or too much in one day. So I let myself take one more paragraph I wrote down, because I read it, and it was real important for you guys. And so that last paragraph, I did write and finished it. So how you guys all doing? Okay? Today's Monday, I guess, huh? Okay. Well, I think I'm ready for bed. I need to start getting up earlier, I think, is what I need to do. So, I don't know. I'm going to get something to drink, and I think I'm going to get in my pajamas and get under my electric blanket. But please, those of you that haven't subscribed to me yet, could you please subscribe to me? I teach all different subjects. Jump around to different videos and look in there, and please subscribe, and please hit my like button. And I suggest that you study all the judicial system. All those judicial systems, there's like 2 rows of them near the top there. If you could study all those, I really worked hard researching that judicial system. It took me hours to get all the info and tape record it, And there's 2. The judicial system starts down at the very beginning of when I started my first YouTube channel show called Miss Melinda's Spontaneous Smart Diva Show. So please subscribe. And I tell life stories, a lot of times spontaneously. And sometimes I may plan to tell you a life story. But, so please subscribe and study some. And you can always you can quit in the middle of the video. You can come back. You can go anywhere and study anywhere, anytime you want. But please subscribe. I would love it to have you aboard. I'm getting a lot of subscribers, and you have to really jump around. And You can't look at one of my talk videos and say, oh, well, I don't like this subject, I'm not going to watch this one, and you leave. But I talk about 10 different subjects in one video sometimes. You know, I'm a spontaneous person, and I love spontaneity. Spontaneity is the key to life. So please subscribe and jump around. Go check out my videos. But I suggest you try to stay through the whole video. And if if it's a long video and you have lost your patience, which I do myself, I'm studying my own videos because I really don't have everything I'm teaching you memorized. So this is getting me to study, and that's what I love, is teaching you around the world. All the foreign countries can see me. And a lot of people that don't have financial aid for college love to come to me for education. I was teaching it in my Twitter, and I used to get 200 to 300 hits. And that was just me talking it with key, typing it, keying it. They couldn't see my face or hear me. They just saw tweets, and I got people from around the world in foreign countries that are hopping on to me. So take a look at all my videos and please subscribe. I'm gonna go get in bed. I'm tired. I love all you guys. Okay, and I hope you keep coming back and keep on looking for Melinda, because we got lots and lots of education. I'm going to be teaching till I can't teach no more physically or mentally. I am loving this. I have always wanted to write, film, produce, and star in my own show, and here it is. I achieved it, and I always wanted to be a lawyer. Well, I graduated associate's degree in paralegal studies downtown Chicago. At McCormick College, you could see Madison Street and Michigan Avenue. You could see the silver Millennium Worm, I call it, from the entrance of my McCormick College. I graduated '08 in paralegal studies, and I'm also a court reporter from that college. But when I went to court reporting, that was back in like 1988, 89, 90, 91-ish, and I got up to 180 words a minute in court reporting. But at that time, McCormick College, we were located on LaSalle Street, right across from the Board of Trade. And the Board of Trade employees would come over to our deli in our building and jump in front of us in line to order their lunch. Like, you're just a bunch of young college kids. You're not under the stress we're under. We're working at the Board of Trade. So we're a lot busier and we're a lot more important. So we're hopping in line in front of you and ordering our deli sandwich. And we used to get our lunch and go eat outside the Daily Center. So I had a really good time going to college downtown at McCormick College. First, the court reporting, I got 180 words a minute. I was happy with that, and I didn't want to bother practicing. You got to get 230 words in the Illinois State test. But I was happy I learned it, and I was at 180. Sure, if I sat for a while longer, a year or two, I could probably get to 230, but I was ready to move on, and I moved to Triton. Went to college at Triton for like 8 years. And so, and I went to college in DuPage starting back in the 70s. So I got a hell of an education. It's just all 2-year colleges. But McCormick College, where I did got my court reporting education, and where I graduated in '08 in paralegal studies, is an upper scale private college. And not just anybody can get accepted into that school. You have to have a good history. And I did it. And my parents are proud of me. And I've been cured off coke for 21 years. I've been cured off of coke. And I've been cured off alcohol 12 years. Cured. There is no alcoholic disease in my body, brain, soul, mind, spirit. I'm cured from alcohol. I am not an alcoholic, and there's no alcoholic disease in my body, brain, soul, or spirit. I'm happy. I am. Yo estoy feliz. I am happy. And come spend some time over at my place here at my YouTube channel. Subscribe and be happy with me. Okay, I'm going to go back to bed. Good night, guys. Love you.